Hi, this is Yogesh Nandi, and in this video, we will see a question asked in the GATE 2023, which is given on your screen. A slab thickness L is shown in figure below has the cross-sectional area A and the constant thermal conductivity K. The T1 and T2 are the temperature at x is equal to 0 and at x is equal to L, respectively. Which one of the following option is correct? Expression of thermal resistance for a steady state condition. So for this one, let's see that we want to know what is the equation for a thermal resistance, which we take it is R. Okay, so diagram is showing like this one as so. This is the diagram. So T1 is the temperature at one side, T2 is the another temperature. Then the lane thickness is given at 0 and at L. Now, so the heat is flowing in this direction from 0 to L. So in X direction, the heat is flowing in X direction. So let's consider this is a hot medium, this side, and this side is the cold medium. And now the heat is flowing. So here the data which is mentioned, and again you can see the Fourier's law is applicable here. So what is the statement of the Fourier's law? The Fourier's law states that the rate of heat conduction through a medium in a specified direction, say x direction in our case, is proportional to the temperature difference. So the proportional to the temperature difference, which is the driving force for the heat transfer across the medium and area normal to the direction of heat flow. If you see this is the slab one, now area, this area we consider. Okay, so we consider this area as normal to the plane. So as per the Fourier's law statement, we consider this area for the heat transfer, and this is a thickness of the slab in direction of heat flow. So with this diagram, we can easily understood that it is flowing from the left to the right. Either T1 is the temperature, T2 is the or the other side temperature, and heat is flowing in the X direction. For that one, we would like to know what is the thermal resistance. So as per the Fourier's law statement, so we can write the equation, another equation that Q is equal to minus Ka dt by dx, where we consider x is the direction, t is the temperature, and differential direction. So if I want to write that equation, so I can just simplify that one with the boundary conditions and all, and we have a generalized equation that is q is equal to ka t1 minus t2 in this case upon it is L. What is K? K is the thermal conductivity, A is the cross-sectional area, this is the temperature difference, this is the thickness, which is Q is the heat rate in conduction form. So I want to know what is the resistance R. Okay, so for that one, I am writing this equation, I rearrange this equation. So I can rearrange that equation as the Q, which is equals to the Ka T1 minus T2. This is my expression upon L. So I can write this equation in form of resistance. So I can write that is delta T, which is the temperature difference upon the resistance R. Okay. So here, what is that R? R is this one. It is R is nothing but it is L by Ka. So where from it comes? It comes from this one. Just we have arranged this one. So I can easily get it is L upon Ka. So I just take this in a denominator and this is R. So the options which is given in this one, the option A is mentioned, it is L by Ka. Option B is mentioned, it is K by La. Option C is mentioned, it is Ka T1 minus T2 upon L. And option D is, it is A by L K. So in this case, we can write that, okay, resistance is this one. This is also the correct equation, but this is the rate equation. So it is the rate equation. So we are not asked the question, what is the rate equation for this one? We are asking what is the resistance, thermal resistance. So thermal resistance, it is L by A. So the option A is the correct one. Thank you.